All right, here we go. So we've got slant asymptotes. Everyone's eyes and ears back up here. Okay, we got slant asymptotes. So our x equals on this one. What makes our denominator equal 0? -2. Okay, we get -2 down there. So x equals -2. That's that asymptote. Now, if we're dealing with our y equals asymptote, remember, we've got to compare our powers. If the power is greater on top than it is on bottom, that tells us our asymptote's going to be, it's going to be slanted. And you have to use polynomial long division to figure out what the equation of that slant asymptote is. Do we have a removable discontinuity, a hole here? No. Tell your neighbor, how come you don't have a hole? Hey, volunteer, how come I don't have a hole? Jaden? You can't cancel anything from top and bottom. Okay, so nothing cancels out. You can't factor the top, can't cancel anything there, so no hole. Okay, in terms of this, to find the y equals, let's go ahead and do polynomial long division. So x plus 2 on the outside, x squared minus, plus 0x minus 2. Remember that place value holder. Okay, got to put that place value holder in there. All right, x goes into x squared how many times? Or x times what is x squared? X. X times x is x squared. Okay, and then x times 2 is 2x. And it's positive right now. Now remember, what do we have to do right here when we're subtracting? Switch the signs, right? You're subtracting both parts. So subtract that, we subtract this, we get -2x. And you bring down the -2. And now you ask yourself again, x times what is -2x? -2. -2 times x is -2x. -2 times 2 is -4. You flip your signs again. This part disappears, and we're left with a remainder of 2. And that's a positive 2, so it's plus 2 over our divisor, x plus 2. All right? So this graph now, this equation we could now write as y equals 2 over x plus 2 plus x minus 2. That x minus 2, we're in the k position right here. That is our slant asymptote. Y equals x minus 2. That is our slant asymptote. So if we go over to our graph and we graph the linear equation x minus 2, so we go to y equals mx plus b mindset, and we go down to -2. That's our b. We rise 1, run 1. This line, these dots, or dashes now that I'm starting to put in, that is your slant asymptote. The line x minus 2. Y equals x minus 2. Questions there? Now your table doesn't change. You still put in your undefined for x. You still put in -2, and that's undefined. You start coming up with points. Now you have to be able to see your graph approaching your asymptotes. So usually what students ask me is like, hey McCoy, did I graph enough here? Do I do enough points? And my answer is, can you see your graph approaching your asymptote? If you can't figure out what it's doing as it's getting closer, then no, you didn't. Okay, usually you want some points that are going to fall right in here, towards the intersection of the asymptote. So you probably want to use like -3 and 4 and 5. Those would be good points to use. And then maybe one way out here, like maybe a -10 or 9. And then over here, this graph on top, we've got to see, well, over here are maybe like 1, 2, or -1, 0, 1, 2, -1, 0, 1, and then maybe way down here again, like at 8 or 9 or 10. I'll use 8. And then you may have to add some points from there. Okay? Which one do you want to put it into? Probably this one. Okay? You could put it into either, I guess, but this one looks a little easier to deal with. All right, now how many of you were able to find the slant asymptote last night? Okay. Now hopefully we can do that today. All right, let's figure out these values. I want you to calculate these points here using your calculator. Go for it. It's come to my attention that these two values give you the same -7. Is that correct? Anytime you get something like that, maybe calculate the thing in between. Like try -3.5. Because what that means is you plot -4 and -3, and you get down here at -7, there and there. It's most likely not a flat line there. It's probably in between there. It's bending. So there's a vertex or a maximum or a minimum, relative maximum or minimum right up in there. Okay? So if you put -3.5, once someone gets that, tell me what it is. We can add it to our table.
-1.86.
-1.86. I hope not, actually, because that will bring us way up here. It'll cross over that asymptote. -6.83 seems like it could be about that, yeah. So maybe like right there. 6.8-ish. All right. So it looks like it's going to start bending there. I think from there it jets out this way, doesn't it? Should jet out towards our asymptote. And same thing over here. What's -5? Did we do that one?
Yeah, it's -7.66.
7.7, okay. So -7 okay. So yeah, I think we're good there. -10 is going to be way off our graph most likely. Okay. All right, so we get that branch down there. -10 is -12.3. Okay. What do we get for -1? It's -1?
Yeah.
Oh, isn't that convenient? All right. How about 0?
-1.
Unbelievable. So in between there.
Is -1.16.
Oh, 1.1. So it's really close to bending right there. Okay. So -0.5, -0.2-ish. All right. And that should start riding along that asymptote and approaching this one as well. All right. Isn't that cool? Dude, you guys got to be pumped. I'm pumped. All right. Just to make me feel better, do we have 1 and 8?
1 but 8 is 6.2.
And 1 is -0.3.
Okay. -0.3 for 1. And 6.2 for 8. Oh, good. That actually works out. Nice. That's totally sweet. Man. Any questions there? You've now seen the asymptotes, what asymptotes do horizontally, right? So before we move on to today's assignment, I want to make sure that we are very clear on what our how our horizontal asymptotes work. All right. So really quick, if I give you y equals x plus 2 over x squared minus 5, and another equation, y equals x squared or 3x squared plus 5 over 2x squared plus 7, and y equals 3x squared minus 4 over x minus 5. Okay? I want to know which one of these, or what the asymptote, the horizontal asymptotes, your y asymptotes are for each of these, based on what we talked about yesterday. What are your y asymptotes for each of those? Okay, figure them out with your groupie. Those of you struggling, really quick, what are we comparing to begin with? We're comparing the powers of the variables out front, right? If the power is greater on the top, or excuse me, on the bottom than it is on the top, what's our asymptote? 0. It's always 0 if the power is greater on the bottom. Because this fraction is approaching 0. If you put in a million, that's a million plus 2, which we don't care about, remember, over a trillion. 1 million over a trillion is 1/1,000,000th. That is extremely close to 0. So this asymptote would be at y equals 0 right here. Okay, how many got that one? Okay, if the power is greater on the top than it is on the bottom, what does that mean? This is a slant asymptote. You have to use polynomial long division on. Okay, so that means over here we would have 2x plus 7 on the outside, 3x squared plus 0x plus 5 on the inside. And we'd have to go through the polynomial long division on that. A bit tougher. I gave you a tough problem here, so hopefully you're not sitting there cranking that one out. Okay? Because now you'd have to say 2 times what is 3x squared. That's a brutal problem. You won't have one that hard right now. Okay? However, that's what you'd have to do to figure out that slant asymptote, just like we did on number 14 a second ago. If the power is greater on top than on bottom. If the power, actually, let's make this an x squared there. There we go. Now we've hit all 3. If the power is the same. Yep.
Divide by the first leading coefficient.
Good. Divide by the leading coefficient. Okay. 3 divided by 1 is 3. This would be 3 trillion over 1 trillion, which is 3. That's your asymptote. Okay. Questions there? Yes, Tyler.
So for the second one, would you have 2 y asymptotes?
No, you'd have 1 y asymptote. It's a slanted one.
So what's the y equals 3 at the bottom? I should just been,
That's for this one.
all I mean is
Okay. So 3 different problems we're dealing with. Okay. Other questions? Okay, you have a review besides what I'm going to assign today. So hopefully you've already finished the front page. It's up on the board. The second page of our review summarizes what we talked about here. It gives you some questions here. It gives you an opportunity to graph them on the bottom. I am not checking the review. That is for your pre-quiz tomorrow. You won't have any time to do a pre-quiz tomorrow. Your quiz will take you 40 minutes. That's what my note says. It's a tough quiz. Be prepared for it. Make sure that you've checked over this review really well and you've summarized your learning. That's why you have it. Okay? That's number 1. The answers are on the board. Number 2, today's assignment is the mixed side. So take a look at the mixed side. On the mixed side, you're going to do 7 through 24 all. 7 through 24 all. Yes? Groans of joy. Very good. All right. Now, please note, how many graphs is that? No, it's not. 6 graphs. Okay. It's not. All right. Make sure you understand how to graph. All right. Let me know if you have questions. The answers are on the board.